Okay, so before I start on this next talk, I would like to go back and revisit exactly what I left off. You see this? You see this right here? Yeah, this was the problem. This was the entire problem. Like, I don't know, 25 characters. Because if you go back to the coffee service from earlier, I just had to do this. I sat down and 30 seconds later it worked. But we're actually creating, or we're pulling from this as a stream of server-sent events, right? And that was going just fine until I got to the client, and I forgot to indicate that it was a stream of server-sent events. In RSocket parlance, this is a channel, right? Because you can make a request and get back an unlimited number of values, which is exactly what we were trying to do. And then I forgot to go ahead and just tell it, hey, don't wait for all the values to come back before sharing any. Share each value as it comes in. So if we look here, and let's do this just to prove I'm not crazy. It works. Okay. Thank you very much. All right, so now that I've gotten that out of the way and I can go on and start with a clean slate, I'm going to go ahead and shut down these things. I feel so much better now. Okay. Okay. To start off with, let's see, I have 45 minutes, or 43 now. Oh, I'm wandering again. Oh my goodness, I'm so sorry. I was told that I spoke a little too fast earlier. I apologize for that. I generally am not quite that crazy fast when I speak. Okay, I may be. But I'm less crazy when I'm speaking than when I'm coding. When I code, I get going really fast because I type fast and I talk fast. Apologies. So we're going to try to fix that this time. This afternoon, or I guess now this afternoon, we're going to be talking about drinking from the stream, or how to use messaging platforms to increase your overall system scalability and performance. You know who I am. We won't go through that again. So distributed systems are easy, right? Yeah, maybe not so much. That's why we're here. Distributed systems come with a lot of challenges. They add several challenges to your systems, but they give you a lot as well, which is why we like them. So again, you know me. Let's skip that. You know about the book. Let's skip that. Normally, I don't give two talks kind of back to back. So, but anyway, if you're interested in the book, we can Twitter. Follow me on Twitter. So a little bit of background, I think, is extremely helpful. Why use messaging platforms in the first place? And if we do look at using them, where do they fit in a distributed architecture? Let's see, do I go on here? No, I want to go back here. Oh, too far. Okay, so where do messaging platforms fit into a distributed system? Come on, you can do this. There we go. To start off with, I think we need to talk a little bit about why we go to distributed systems to begin with. In the world of monoliths, and we all have monoliths in our organizations, right? Everybody has one or more monoliths. Monoliths aren't necessarily inherently bad. The problem with monoliths is that they incorporate a lot of different capabilities in one thing, which can be good, right? But the problem with that is that no matter what collection of capabilities you have in a single monolith, there are going to be some capabilities that are used a lot. And there are going to be other capabilities that are barely used at all. And when you scale the monolith, you have to scale all of them together as one unit. So I always think of a retail site. If you do a good job with your retail site, your shopping site, and you choose your products well, they're good quality, they fit for your target market, then you'll have a lot of sales. But you won't have a lot of returns. Your return module has to be there, right? I mean, it should be easy to return items when someone gets the wrong item, or they don't like it, or they don't like the color, or whatever. But if you're doing your job right in product selection, and your market fit, then you're going to sell a lot and return very little. So when you need to scale out that selling part, you're scaling out all of it together. So it's this big chunk that you're having to scale. That also brings in things like contention issues or in the case where your system thought it was the only one of its kind, and now there are 2 or 3 or 10. So we often start looking at microservices as a way to tease out and extract those functionalities that are used a lot and to scale them separately, right? So it's easier to develop, faster to develop that changing functionality. It's also easier to scale out and back in that functionality because you're not bringing along a lot of other less used functionality with it. So it makes development easier, it makes deployment easier. But when we start doing that, sometimes, well, most times, we realize pretty quickly that if we have a bit of functionality and we peel that out from our monolith, it's not just a single microservice. In most cases, service A has to talk to service B and service C and service D and get their responses. Maybe if you're placing orders, it's checking inventory and it's placing, it's determining which warehouse it has a certain number of those items and where it will ship from, and it's checking your customer's credit and things like that. So you, instead of scaling that one microservice, you're actually starting to realize that you're scaling a small cluster of microservices. So even though you're broken out of the monolith, you're not extracting one thing you can scale independently, you're extracting clusters of services you're scaling together. So it's not necessarily bad, but it's not quite that level of granularity maybe we were hoping for. So we see there's some degree of coupling, locational coupling, temporal coupling, because if service A has to talk to service B, and it has a certain number of requests it fires off to service B, chances are you're going to need 1 for 1, roughly, service A to service B. And they have to be available at the same time. So if you need to spin up a second instance of service A, chances are you'll spin up a second instance of service B so they can communicate, and a third and a third. So you start realizing that you're not getting the level of scalability perhaps you'd hoped. This is where things like messaging platforms come in because they're that next level of scaling. So before I get into exact examples, what I like to say is that you have different you have the ability with messaging platforms to isolate, to decouple temporally as well as locationally. Because when a consumer of a message gets a message, when it sees it has a message, it doesn't care where it came from. It just checks its pipeline and says, oh, I have a message to process, and it processes it. It also doesn't matter whether the producer of said message is even available and online, because that producer can push a message into that pipeline when the consumer is not available. And the consumer, when it becomes available and starts consuming that message, your producer may not be online. So you have things like retention guarantees and durability and delivery guarantees that allow your messaging platforms to take you kind of that next level of decoupling your various services. Examples include, well, there are several examples, right? I kind of look at the top, what I consider to be the top ones, things like RabbitMQ and Kafka. Each of the major cloud providers has, well, several different options. But among those, I typically think of like Amazon's, I just went blank. Microsoft Event Hubs, Google Cloud's PubSub, and Amazon's Kinesis, right? So those are the three I consider to be the first among peers. There are many, many others. And then there are others offered by other companies as well, other organizations. But even among those, the only two, those 5 that I mentioned, the only 2 that are fully open source are RabbitMQ and Kafka. Now, maybe that's not important to you, to your organization. Maybe it's very important to you and your organization, but I leave that for you to decide. I typically think of RabbitMQ and Kafka as the first among those peers because 1, they're open source. 2, you can run them literally anywhere, from your laptop to your own data center to any of the major cloud providers to third-party hosts. So you have the ultimate in flexibility and portability across those 2 specifically. So what is Spring Cloud Stream? Well, if we could all standardize on one messaging platform, life would be so good. But we don't, right? So perhaps your company has standardized on RabbitMQ. and you acquire a company, or your company is acquired by another company, which has standardized on Kafka. So even if you've standardized on one, as soon as you are acquired or acquire a company or maybe have a partner that's using something else, you're back in the integration game, right? So Spring Cloud Stream gives you a way to abstract above whatever messaging platform you may be using, or platforms, right? Because ultimately, as developers, we need occasionally to choose and set different configuration settings, but generally speaking, what we want is a place to push messages and to consume messages from, right? And we want to be able to route them various different ways. We don't necessarily need to, every day, configure replication. We need to know that messages are delivered where they're supposed to be delivered, when they're supposed to be delivered. Spring Cloud Stream helps you step above the lower level concerns unless you absolutely need to get to them. And then, of course, you can, but that auto configuration, thanks to Spring Boot and Spring Cloud Function and Spring Cloud Stream, gives you a lot of capabilities for free that you can concentrate then on the business value versus on the plumbing. So, all right, let's see. Well, I think I've covered why use it, right? It makes your life a lot simpler and allows you to deliver real business value faster. Now, in a volatile world, sometimes we have to make quick decisions, quick changes. If your manager is known for quickly changing everything underneath you, don't raise your hands, don't embarrass your managers, that's bad. Eating is good. But if you have a volatile environment or a manager who says, hey, look, I know we decided on RabbitMQ last year, now we're going to change everything to Kinesis, it would be great if there were a way to isolate yourself from that wave of change, right? To be able to do that in a way that's not disruptive. And there is. Spring Cloud Stream gives you those capabilities to rather easily and handily switch out even entire underlying messaging infrastructures. And we'll see that here shortly as well. So, the first time I gave this talk, I started right into code, and I had a great time. But I had a couple of people say, well, why did you do this? Or how did you get here? And I think sometimes it's important to get context, right? So does anyone use Google Maps, Apple Maps, any maps? Isn't Naver a mapping app? So when you key in your address that you want to go to, it'll show you the map, right? And then it'll tell you the directions. Turn here, turn there you are. So that's context, right? When you see the map, you can see, oh, I need to go there. That's where I'll wind up. This is context, right? So we're going to start with Spring Cloud Stream and a messaging platform. I'll start with Rabbit. It doesn't matter what you start with, but I like Rabbit. Rabbit is wonderful. And I like to show kind of the power behind Rabbit, because in Stream, because with Spring Cloud Stream, there are 3 predefined interfaces, right? One is your source, and by default, that's the thing that produces values. You have a sink, which is the thing that consumes values, and that's the end of the road. There's no further processing done on that message. It's just done. And then in between those, the source and the sink, you may have any number of processors which take a value, manipulate it in some way, and pass it on to various other processors or sinks. Now you can combine these in various different ways, and it's very powerful to do that, right? So you can create some really interesting and intricate routes. And that's why we use messaging platforms, among other reasons. But at the very simplest level, you have 3 things. You've got a producer, a consumer, and something that transforms, right? So if you need to scale those, it becomes very easy. There are a couple very small configuration settings you can choose that allow you to scale out. And I show the source being one and scaling everything else, but you can scale the source too. But what typically happens in a system is your source can push values rather quickly. But when you transform them, when you consume them, you may need to scale out. And you can scale independently by using messaging platforms in between. So I always call these pipelines in between. In this case, they're Rabbit pipelines. I don't like to use the terms exchanges and queues or topics, because then you're talking Rabbit or Kafka or some other specific brand of messaging. But they all typically are pipelines of one form or another. So I try to stay at that higher language abstraction. If you need to switch out, if your boss comes and says, nope, we've changed to Kafka, can you make that happen? How quickly can you make that happen? You can do that. And it's not overly traumatic, as I mentioned, and we'll see how to do that as well. And then, of course, like most of us do, we have to use both, or we have to use multiple messaging platforms. And that's fine too, because Spring Cloud Stream makes that rather trivial to do as well. You might have guessed I'm a fan, right? Okay. Now, I do want to step back a moment, because what I've been talking about so far has been kind of the legacy umbrella of Spring Cloud Stream. And Spring Cloud Stream has been based on Spring integration. Spring integration allows you to bring a lot of different underlying or various different components, sources, destinations together. But Spring Cloud Stream is not just a wrapper for that, right? It's abstracting some specific capabilities to deal with messaging platforms, as well as evolving an API that's actually much closer to foundational Java, right? So the traditional way of dealing with things in Spring Cloud Stream has been source, processor, and sink. But if you think about it, in baseline Java, these parallel really well with three concepts that are implemented in Java itself. A source is a lot like a supplier. A supplier creates values, right? A sink is a lot like a consumer. It is a consumer. It just consumes those values, and nothing further happens to those values. In between, you have a function which takes a value, an object of one type, and produces an object of another type. That's a processor, right? So you can start to see that the abstractions, the leaky abstraction that was in the existing Spring Cloud Stream API can actually be reduced or eliminated entirely. This looks a lot like a very basic Java program without a lot of Spring specifics mixed in, and yet it still gives you all the same power. So I'm going to be talking about the evolved API and showing you that today. The legacy API still works brilliantly, but I think this is a much cleaner API, and it's just super fun to deal with. So with that, again, Moss is back. Let's code. All right. I like Moss. If you have not seen the IT crowd, watch the IT crowd. Okay, so let's see. Let me refresh this. Ha, dark mode. Oh, so nice. Okay. So we are going to create 3 different applications, right? 3 different services. One which will produce values, one which will consume them, and one in between which will transform them. And then we're going to play around with those just a little bit. So again, I will create a Java project using Maven, the current version of Spring Boot. I'll change this to the Hecklers. This will be my source, right? And we're going to bring in a few different things. I'm going to keep it really, again, fairly straightforward and simple with the dependencies. We're going to bring in Spring Web, and then Cloud Stream, and then Cloud Stream, when you bring in this dependency, it even tells you, look, if you want to deal with a messaging platform, that's great. Cloud Stream will help you do that. But if you do, you will have to bring in a binder for Kafka, RabbitMQ, whatever. A binder is what makes that abstraction possible. So it's your go-between, right? So you can deal at a higher level of abstraction regardless of whether you're dealing with Rabbit or Kafka or Kinesis or what have you. So I'm going to bring in Rabbit, and I'm also going to bring in Kafka because, yeah, why not? And then Lombok, because lazy developer, right? Okay, so we've got all of our dependencies. We'll go ahead and generate our project, and that's fine. I'll just put that out there. And then I'm also going to just, to speed things along, create my processor and to create my sink. And we will work on those projects as we go. But we'll start with our source. Okay. Nope. I don't know why that opened that. That's so weird. Okay. Oh, it could be because I was in the wrong directory. Okay. That looks better. All right. So the first thing I'm going to do, oh, IntelliJ. Well, we won't be doing that now. Okay. All right. So I have a couple of different things I can do with this in examples, but again, I'm a big fan of coffee. So if you made it through the first one, I think you deserve a little more coffee to get through the second one. So I'm going to just create a couple of classes here at data alerts instructor, coffee. Actually, this will be a wholesale coffee, because for this example, what I like to do, since we're going to be dealing with a source, a processor, and a sink, is go all the way from a coffee farm, which, by the way, I visited a coffee farm. I've picked the coffee beans. Oh, if you get a chance to go, it's just like heaven. Anyway, so from the coffee farm, the coffee farmer will ship the beans to a coffee plant, a coffee roaster. The roaster will clean the beans and filter them, and then they will roast them, and they'll package them. And then they'll send the packages to a coffee shop, right? That's the end of the road. The coffee shop gets the coffee, makes us our glorious coffee, and then we enjoy, right? Okay, so with this being our source, we're going to start at the coffee farm. And this will be what we call a wholesale coffee, the coffee that's sold in bulk to the coffee roasters. And this is pretty simple, right? We just have an ID and a name for our coffee. That's all we really care about at this point. So we need some way of creating these coffees and pushing them into our pipeline. Now we could create them manually by hand, but that sounds like a lot of work, and I'm lazy again. So we're going to create a component to do that for us. So this will be our coffee generator. Sounds lovely, doesn't it? So I'm going to create a couple of things here. I'm going to create a list of names, and these will be our coffee names. Now I have some really good coffees I can recommend, as you might have seen earlier, if you were here earlier. If not, well, you missed a total embarrassment at the end, but it all wound up fine. The end. Happy ending. So we have Café Cereza, which is an excellent coffee. Don Pablo, which is an excellent coffee. And Caldi, which is an excellent coffee. And Folgers, which is a terrible coffee. We're not going to use that. That's horrible. Terrible. Don't ever drink Folgers. It's like, I don't know, it's terrible. I used to have a colleague who would shout out Folgers. Anytime I would get to this part, he'd yell, Folgers. He had to go. He's gone. So, okay, so we have Kona coffee, and that's fine. So we have our names. I also am going to create a random object for a little bit of randomness, right? Because random is fun. And then I'm going to create a generator method, generate, which will generate my coffees. So return new wholesale coffee. I'll use UUID to give us a random ID, right? And then I will extract from names. I'll use my randomizer here to take the length of the names, the size of the names, and just grab a particular name and send it back. So that will generate a random coffee. Now that is great, but that doesn't get us a coffee into the pipeline yet. So we need to do that. So at this point, what I'm going to do is just create a configuration class, and this will be our coffee grower. This is our farmer, and this is the person who will send us our glorious coffee beans, right? So let's see, I need to do a couple things here because, again, lazy, I need to enable scheduling, and then I need to inject my coffee generator. And again, lazy, I'm going to use Lombok to inject that into my constructor, so that's fine. So now in order to send this, I need to schedule at a fixed rate. Let's see, scheduled, that's helpful. Fixed rate of 1 per second, 1 every 1,000 milliseconds. And I'm going to create a bean at bean. Now remember, I told you that for a source, it roughly corresponds or does correspond exactly with a supplier. And we're going to create a supplier of wholesale coffees. And we'll call this method send coffee. Sounds like a plea for help, doesn't it? Okay, so we're going to return a supplier. We have our generator, and we're just going to have it generate a coffee for us. That's it, right? Now, I do need to let's see, I need to go to my application properties. I'm going to assign a server port of 0, which just means that for Spring Boot, when Spring Boot application starts, when it sees server port equals 0, it just gets a random unused port. So that's good. So that keeps us from port conflicts. And then I need to indicate my bindings. Now in this case, I have a send coffee method, right? And this gets really, really crazy simple because I just have a send coffee method. So I'm going to put that as my binding. As a source, it only has an output. So I have an output channel, and I have this is my one output, right? So with when it comes to Spring Cloud Function and a reactive model, we can actually have multiple inputs, multiple outputs. In this case, we have one, and it's 0 offset, so we'll just stay with this. We call those tuples, by the way, but in this case, it doesn't matter. We just have one. And I'm going to tell it to send to a destination of a pipeline called processor. I also, because if you look at my POM, which I don't have loaded, Spring Boot has auto-config, right? Its auto-configuration will do a lot of things for you. And you said, I want to deal with the messaging platform. And you gave it, well, wait a minute. You gave it 2 binders. Now, Spring Boot will auto-configure your application brilliantly when you're precise. But when you're cloudy, when you're muddled, when you don't give it specific help, it says, well, which do you want to talk to? Do you want to talk to Rabbit or Kafka? I need more specifics here. So you can either comment one of these out, or you can just do this. Binder equals Rabbit. So simple, right? Now, I know that we're going to want to change this over to Kafka at some point, so I'm going to go ahead and put some Kafka properties here. So we're going to say, please, Spring Cloud Stream, have the ability to automatically add partitions to Kafka. And the minimum we should start with is 4. And that's good enough. So that gets us started with our source. So we're off and running with that, or we should be. So let's go ahead and we'll create our processor and our sink, and then we'll put it all together. So here's our processor. There we go. Once again. Come on, it's indexing. Wow, so slow. Okay, well, something didn't happen right. Let me go ahead and reopen that. Seriously, IntelliJ, come on, you're killing me. Okay, it's just the day for it, I guess. So let's try deleting existing project, import. Whew, okay, well, it is here, right? Let's check this out. We can get there from here. Okay, there's always a way. All right. So this is our processor. So our processor is going to be receiving what from our source? It's going to be receiving wholesale coffee. So at data, at all_constructor, class wholesale coffee, private final string ID and name, and that's fine. But our processor will transform this wholesale coffee into a retail coffee, right? The stuff we're going to send out to our retail establishments, so retail coffee. And with that, we have, well, the same values to start with. So we have an ID and name, that hasn't changed. But in this case, we do something. We roast it, and then we package it, right? So once we send it out, it will have a certain state. Now, the way that you should send all coffee out is as whole bean, so that when the purchaser gets it, they grind it and brew it, and it's super fresh, right? But there are some of us who, I don't know, don't have a coffee grinder or are traveling, and we need to accommodate that. So we want to also send out some bags of ground coffee as well. So we have 2 different states. So we have, for each individual bag of coffee going out, it'll either be whole bean or ground coffee. So now we just need to create a configuration class, which will be our coffee roaster. And for a little bit of randomness, again, we're going to, create a new random object, and then we'll create our bean. And this is a function, right? We'll receive wholesale coffees, and we'll produce retail coffees, and we'll call this process it. Now, this is pretty simple. We take a wholesale coffee in, and we transform it. I'm going to add a little bit of transformation here. So we will create a retail coffee. Our coffee equals new retail coffee, and we'll use our W coffee's ID. The ID hasn't changed. We'll use our W coffee's name, our wholesale coffee's name. And then for a bit of randomness, so random next int, we have two states, right? Whole bean or ground. If that equals 0, we'll say that we're going to produce and send out a whole bean coffee. If it's not, we'll send out a ground coffee. And then we'll do our coffee dot sout, and then we'll return our coffee. Okay, so then if we go to our application properties, once again, we set a random server port, or have boot assign that. And then for our bindings, we have process it, and we have an input channel. And in this case, the destination is what? It's processor, right? That's where we were sending the one before, to a channel called processor, right? So we receive it on a channel called processor here. And then, of course, since this is a consumer, we have to, or we can specify a consumer group. If we have multiple consumers, multiple processors that are not in the same group, they all get a copy of every message. And that's what's called a fan-out pattern. If you need to fan out messages, that's perfect. But if you need to scale, you want them all in the same consumer group. That way it's a competing consumer pattern. And instead of having one processing messages, every message, they take turns. And that way you can scale out or back in. So we assign it the same group, and then of course, because we need to specify our binder, because we have Rabbit and Kafka on our class path, we're going to assign that to Rabbit. And then of course, for a processor, we have an input channel and an output channel. So process it, out, 0, destination, sync. We'll just call this our sync pipeline. We don't need to specify a consumer group because in this case, it's an output channel. It's not consuming, it's producing. And that, of course, we actually should say our binder for this is Rabbit. And then again, because we'll switch to Kafka, we say add a couple of Kafka parameters for later. And there we go. So now we need to create our sync. And then the party starts, right? So nice. Okay, so, oops. Oh, I just closed everything. Good thing IntelliJ is fast. I was trying to hit the Command 1 to close out the project tab, and I hit Command Q. Oops. All right, so let's go back to this. All right, so here's our sync. Now let's see if I can do that with a little more accuracy. Oh, that's much better. Okay, so application. Wow, IntelliJ is just not having it today. So we'll do this the hard way. I'll navigate. It's so hard. It's so tough. You have to do all this. This is okay. So once again, in this case, now this is our sync. Our processor has taken wholesale coffees, transformed them into retail coffees, and sent them on. Our sync should only get retail coffees as a result, right? So at data, at all-args constructor, what is going on here? Let's see. Well, come on, Maven. Re-import. Let's try that again. Haha, okay. We're back in business. Okay, class, retail, coffee. Sometimes your tools just fight you, right? You just have to carry on. So we have a string ID and name. And then we also have an enum for state, and that's whole bean and ground. And then we have state. Nice. Okay, so that works. Now, here we need to once again create our configuration class, and this will be our coffee drinker, because at this level, this is our consumer. That's us, right? We're the consumer. and we want to create a bean here that's a consumer bean. And it's a consumer of retail coffees, which sounds delightful, doesn't it? And this will be our drink it method. And then as a consumer, return. So this will be our, well, actually I could do this. We'll take a coffee and we'll do a system.out.println line coffee. But of course, we can just do that as a method reference, and that's even cleaner. Now, we need to, again, go to our, well, actually, we'll go to our application properties, server port 0, so no port conflicts, and then Spring Cloud Stream bindings. In this case, it's drink it in, yes. It's an input channel for our sync, right? So we need to specify our destination, which is just called sync, and our group, which is also sync, and then here is our binder, and that's Rabbit. And then because we, again, know we want to go to Kafka, we say yes, make that auto add partitions true, and our minimum partition count is 4. All right, let's start it and have some coffee. By the way, I am running RabbitMQ and Kafka and Zookeeper locally in containers, but if we have time, we might. I can point to networked or hosted instances as well, and it works just the same. So we see that we're connected here, right? So we look at this Rabbit connection factory. Let me do that. So we see that we're connected to Rabbit, and we're listening to our pipeline called sync. So if I go to my processor and I start that, oh, well, there we go. Let's try that again. All right. And wow, IntelliJ just is really giving me grief here. So let's see. Interesting. Okay, so let's try to run. Not all tests. Wow, let's see here. So there we go. Off and running. We will persevere. All right, so here we go. We have our Rabbit connection, so our processor is up and running. Now we just go back to our source, and we'll start that. And then if we've done everything right, of course, we should see things coming across the wire here, and of course we do. Because live demos always work. Yeah, they don't. But anyway, so that works. Oh, thank you. Yeah. I don't know whether to feel pleased or embarrassed. But okay, it works, so that's great. Now, what we've done in very short order is create a source, a processor, and a sync. We've started at the fount of all coffees, the coffee farm, the coffee plantation. And we've taken those coffees and we've processed them and passed them on all the way to our cup. And we've done that using RabbitMQ. But what happens if you need to switch to Kafka? That's awkward, right? So let's go ahead and we'll stop our source here. Now I need to ask this part, are there any managers here? Any leadership, managers, presidents, vice presidents, CEOs, CTOs? Okay, good. All right. I'm kidding. I mean, you're always welcome. But I will tell you this. If your manager comes and says you need to change things from Rabbit to Kafka, from Kafka to Kinesis, or what have you, this is how hard it is, all right? I'm going to go here to my, well, it doesn't really matter what order. I'm going to go here to my sync, and I'm going to change this binder, and we're done. Okay, so that's our sync, right? So we'll do that. And then I'm going to go to my processor, and we'll go to our application properties, and we have two here, so Kafka. This is exhausting, isn't it? This is a lot of work. The good news is you can externalize these. So if you're picking these up from your environment variables, you don't even have to rebuild your application. You just restart. You change your environment variable, you restart, and you're off and running on a different platform, an entirely different platform. So let's go to our source. Let's see, source. And here we also change this to Kafka, and we'll start that. Now, before that starts, what I want to do is show you that you see here that we are connected to Kafka, as it shows. So it even shows you your version number and stuff. So it tells you, yes, you're connected to Kafka, and yes, you're passing and transforming values across the wire on Kafka, which is super powerful. It took us less than a minute to change our entire underlying messaging structure. So that's great, right? That's not bad. But remember I said that never, ever, ever do we get the chance to only use one platform? Yeah, that's a reality, right? So what happens if you need to deal with both? Let's assume for the time being that our sync will stay on Kafka, right? So that's going to listen on Kafka. Let's say that our source, though, this is an application provided by a customer or a partner, and they're using Rabbit. So what do we do now? Well, I'm going to go ahead and restart that, but then I'm going to go to my processor because that's where we need to accommodate this, right? We need to listen on Rabbit and produce values and send them out via Kafka. And it really is that simple. So while that starts, I'm going to bring up something here. And let's see, so we've got this and it's working again. So here's our processor, and here's our sync, and we're getting our whole beans, or our ground beans. So that's all good. Okay, so now the one thing that I do want to show you, if I can find this, is DATS. Let's see, so I need to go down here and grab a few things here, because I love to show when you're using hosted platforms. So let's go back to our source, and we'll stop that. Let's say that sometimes people ask, how hard is it if I don't want to work locally? Because all of Spring is kind of optimized around that developer experience, right? And the auto configuration works well in hosted environments, but it works optimally on your machine, right? It works optimally to help you be the most productive you can be. So it assumes local ports, local host. How hard is it to point to a hosted instance? Well, there are 4 properties for Rabbit in particular, and it's similar with Kafka. You have a host, a username, a virtual host, and a password. I'm not too concerned about the password stuff. This is just a small hosted instance, so I'll trust you on this. But I'm going to go ahead and use a hosted instance of Rabbit to go ahead and push those values and retrieve them. So that's our source. I'll restart that. I'll go to our processor, and we'll do that. Still, same code. Code has not changed. And then we see we just pick up where we left off, right here. It's really that simple. Spring Cloud Stream is something that some people have been using for a long time and love it, and some people are like, where has this been all my life? And I'm here to tell you it's only getting better with the new evolved API, which is continuing to evolve and become more and more simple, more and more standard, out-of-the-box Java-like. It just makes it dead simple to connect pipelines and do so in various different established patterns, as well as new patterns that you may have that fit your specific use cases. So check it out. Okay, so with that, let me go back to, well, actually, let me kill that before I let it just run forever, because otherwise I do. All right, we'll go here, and we're going to finish up on time. How awesome is that? I mean, that just doesn't happen. All right, so with this, if you want to know more, please do check out my repo, Drinking from the Stream. That's out under my GitHub account, obviously. And then if you want to know more about the amazing goodness that is Spring Cloud Stream, by the way, all this is open source. I know you're probably well established in the Spring world, but if there's anyone out there who isn't, everything I showed you is 100% open source. 100%. Check it out on GitHub. If you go to the Spring Cloud Stream project page, you go to the docs, you go to how-to guides, you go to GitHub, and you can see all the code out there itself. So check it out. And if you want to reach me, I am available via email, although I don't check it as often. The best way is Twitter. You can publicly tweet me, you can direct message me on Twitter, it's all good, it's all open. And if you are a Kotlin fan, check out the Kotlin repositories too, because Drinking from the Stream, Kotlin has all the same capabilities, just using Kotlin. And with that, with 5 seconds to go, thank you.